Welcome again. As promised in the previous video, on the previous class, we say that we are going now to give analysis of the geometry of an ellipse whose center is the origin and then the major axis along the y-axis. So analysis of a vertical ellipse. And then we refer to an ellipse whose center is origin, major axis on y-axis. So let's draw the sketch. So this is X, this is the center, this Y. So we draw this. So this is what you have. Let's one of the focus be here. This is the center. Another focus to be here. There's a vertex here. There's a co-vertex here, co-vertex here, co-vertex here. So with this, let's label it as this one to be V1, this one F1. This is the origin or the center. This is B1. Call this one B2. Call this one F2. Call this one V2. So that's what we have. So with that labeling, we always know that the distance from the center to the vertices is A units. So therefore, this will be 0, C, comma A. This will be 0, minus A. And then this will be 0, C. This will be 0, minus C. And then distance from this to the co-vertices, center to the co-vertices is B units. So this would be B0. This other one would be minus B, 0. Obviously, this one is 0, 0. So the first thing that you are going to say about this graph is that the equation is given by x squared over b squared plus y squared over a squared equals to 1. And always a is greater than b and a is greater than c. And then relationship between a, b, and c is that a squared minus b squared minus c squared gives you b squared, from which you can get the relationship between the three values a, b, and c. And so we have given the coordinates of the vertices, co-vertices, and then the foci. So the next thing, there's this line, these two lines, actually they're the same, called the latus rectum. So these lines, which are perpendicular to the major axis and passes through the foci, are called latus rectum. So we can be interested in knowing their length and also their end coordinates. So therefore, let's specify this be the end, this be the end, this to be the end, this other one to be the end. And let's label this as M1, M2, this one as N1, N2. So what will help us to know the coordinates of these endpoints, M1, N1, M2, and 2, is this value here. You know, this horizontal line, and this horizontal line, every value of y is fixed. So therefore, we say that x squared over b squared from this equation is 1 minus y squared over a squared. And because here y value is known to be c, so we'll say x squared over b squared equals to 1 minus c squared over a squared. And so we have x squared over b squared equals to LCM is a squared. So a squared minus c squared, solving this. And we know a squared minus c squared is b squared. So we say x squared over b squared is nothing but b squared over a squared. So when you solve this, you get that x squared is b power 4 over a squared, which tells you that getting the square root on both sides, x will be plus or minus b squared over a. So therefore, the ends this one here, y is always, so x will be now b squared over a comma minus c. Here we'll have minus b squared over a comma c comma minus c. And then on this other end, we'll have b squared over a comma c, and this other end will be minus b squared over a comma c. So those are the ends of the lattice rectum. Then the length of the lattice rectum. Now, knowing that from this is x is 0, then this one is b squared over a, then it tells you that from this f1 to this m1 is b squared over a units. Similarly, this distance is b squared over a units. So the distance of m1 and 2 or n1 and 2 will be simply twice b squared over s over a. So length of lattice rectum will be 2 b squared over a, and then length of major axis. Major axis is the distance from B1 to B2. And when you measure that distance, you still get 2a. Length of minor axis. Length of minor axis is the distance from the co-vertices joined together. So B1, B2, and that one should give you 2b. And eccentricity, which is the ratio of distance from the center to the focus over the distance from the center to the vertex, is C over A, and this thing must always be less than 1. So this is how we analyze the vertical ellipse. Thank you.